Okay, it didn't crash. Wow. 10% came through. Okay, so this is, like I said, Notes 15, solving by graphing. And again, you're going to need a ruler. So make sure you have a ruler. And again, I'm going to graph, like I was saying, both of these equations on one graph. And that is what a system of equations is in math. A system of equations, multiple graphs on one coordinate plane. And so what is the solution to a system of equations? That's what we need to find. And the solution is where the lines, in this case, intersect. Okay? Where do they cross? What is the point at which they cross? You know, lines intersect in a point. So let's find that by first graphing this one in purple. So first what we're going to do is we're going to name our B, which is our y-intercept. So I'm going to zoom in on this a little bit more. Get this. Okay, so we're going to plot our B. Our B is -3. So that means we're going to go to this graph and find -3 and plot that right there. That's one of the points on our line. Then we're going to trace our slope, and in this case our slope is 1/4. We always are going to be using this y equals mx plus b, at least in this lesson. Okay, we're going to start easy with slope-intercept form. Later this week, it's not going to be in slope-intercept. You need to put it in slope-intercept to see the m and the b. But we're going to plot that -3, and then we're going to go trace our slope from there. So in this case, our slope is 1/4, and you need to know how to interpret that. What that means is you're going to go up 1 and right 4 from the B, always from the B. So up 1, right 4, 1, 2, 3, 4. That's going to be our second point. You could get another point on the line by also going down 1 and left 4. Just switch both of the arrows, and you can get another point on the line. Okay, so that's right here. And I'm going to put both of those on there, and you'll see why in just a second. Okay. So I'm going to draw my line connecting the points. Nice and clean. Really important you have a ruler for this lesson because the lines need to be clean for you to see the correct intersection point. Now we're going to go graph the second equation in red. So this equation has a b of 2. We're going to always plot that first. Okay, that's a little bit better. Some more light. Oh, that's way better. Okay. So plot the b, and then our slope for the second one is 3/2, and we need to know how to interpret that. That means from the b, we're going to go up 3 and right 2. We could also switch both of the arrows and go down 3 and left 2. In fact, that's probably more helpful for this, but I'll show you the up 3 and right 2. Up 3, right 2. To get to that second point. We can also go down 3 and left 2, and that gets us to our next point. So let's connect. With a nice straight line. And at this point we can see where the lines intersect. And that right there, folks, is the answer. All we have to do is name the point that they intersect, both the x and y coordinate, and we need to understand what that means. The x coordinate in this case is -4, and the y is also -4. So what you can do is you can write x equals -4 and y equals -4. If you didn't have this graph here, okay, so let me just, before I say anything else, I can just put a period on this end of the sentence and say, here's the answer. And you would be good to go. All right, but let me just explain something that's important, that's helpful. That is that if you never had this graph at all, what this really is, x equals -4, y equals -4, are the two values for both x and y that make both of these equations true. So if you plugged in -4 for x in both of these and -4 for y in both of these, they would both be true. And you can see a graphical representation of that. This is where the line, this is the only point that these lines share in common. And that is where the x and the y is the same for both. And so that's the solution to the system of equations. All right, I just needed to give you that extra there. Now for the sake of the video, I'm going to just do one more example and then we'll do some more in class. Again, feel free to pause whenever you need to. Go to the back on number 5. I need to show you another case of something. Okay? Let's graph both of these. Top one in purple for me, bottom one in red. So again, I'm going to plot the B. That's 2. Goes right here. And I want you to do this assignment in Delta Math. I'll have the paper worksheet for you if Delta Math doesn't work for whatever reason. But Delta Math is perfect for this because you just click and drag and you've got a perfect line. Whereas here you need a ruler and all that. Maybe you draw the line crooked, maybe, you know. So, and Delta Math tells you if you got it right or wrong. Then I want to trace my slope, which is -5/2. Now, you can take the negative and put it with the 5, or you can put it with the 2, but you can't put it with both, because then that means it's positive. Negative over a negative is a positive. So either put it with the 5 or the 2, not both. So in this case, I'm going to go down 5 and right 2. A lot of you guys are still a little shaky on how to interpret a slope. You need to know how to interpret the slope, meaning know what that means. Down 5, right 2. From the B, always from the B. Down 5, right 2. There's my second point. And I'm just going to draw my next line. Or not, sorry, my next 2 points without making the line quite yet. So for this one, I've got a B of +1. So I'm going to plot that B. Then I'm going to trace my slope. And what do you know? The slope is actually the same. So when I say the words same slope, what do you think? What word do you think? From last week. Parallel. That's what you should be thinking. Same slope, parallel. That's what we learned last week. Well, at least what you should have learned. So from this B, you're going to go down 5 and right 2, just like the purple line. That's here, and then here. So I'm going to connect the red dots, and then I'm going to connect the purple dots. And what do we have here? We have 2 lines that are very close to one another, but do they ever intersect?
No.
They never do, because they are what? They're parallel lines. So this is a system of equations, and we know, and they're very close parallel like that. We know that the solution to a system of equations is where the lines intersect. But you just said that these lines never intersect. So is there a solution? No. Okay, so parallel lines means no intersection point. So you can write this off to the side. These are just notes. So what are you going to put? Therefore, and these are everything I just wrote right there are just notes for you so you can understand why there is no solution. Therefore, and here's what you would write. No solution. Because there's no intersection point. That's the answer. Okay? So, one really easy way to know if there's no solution in a system of equations is if you see the lines having the same what, guys? Same slope, right? See, these lines clearly have the same m. So because they have the same m, I know that they're parallel, therefore they never intersect, therefore there is no solution.